6.2, transforming quadratic functions. Let's start by writing the parent function. The parent function is f of x equals a times x squared. Remember, this is the most basic quadratic function that there is. And we're going to transform it, meaning the parabola for this function, we want to move it around, just like we did in the Desmos marble slide activity. So say we want to move this function left or right, and we know if we're moving something left or right, that affects the x value. So it moves along the x-axis. So if we were going to move it along the x-axis, we must transform the parent function's x values. If we want to move the function up and down, we must transform the function's outputs, meaning their y values, or in this case, the f of x. So let's say we are going to transform it, and I'm drawing the arrow to indicate that I'm transforming it. Because we're transforming it, I'm going to use g of x because this will be our new function. And let's say a stays the same. Nothing is affected to the a. But let's say we want to move this function left and right. That means I must do something to the x value. So if I want to move it right, I will have minus h values. Oops, let's put that back into white. Minus h values, which will translate this function left or right. If I want to move it up or down, say I want to move it up, that means I must add a k value to move it up or down. And this right here, class, is what we call vertex form. So in your notes, make sure you are highlighting or writing it in bold, but this right here is vertex form. Do that in something that stands out, maybe. Oops. No, that doesn't stand out. And vertex form is g of x equals a times the quantity of x minus h squared plus k. So let's go ahead and break down some of the components of vertex form. Okay, so because of the name vertex form, we can actually locate the vertex because the vertex isn't always going to be at the origin. So in vertex form, it's kind of nice. It's the new values that have been added to the parent function. So in this case, vertex form, or I should say the vertex is indicated by the h and k value. So from this form, you can identify straight away what the vertex is. It's whatever the h value is, whatever the k value is. We can also identify the axis of symmetry. And the axis of symmetry is going to be essentially the x value of the vertex. And the x value is represented by the h. So the axis of symmetry is your h value. Let's note some other things. So if say my k value is a positive number, then that means it's going to translate my parabola up however many k units. So let's say if k is greater than 0, the graph moves up. So let's just keep it in simple terms. The graph moves up. That means if k is less than 0, the graph moves down. So it moves up if k is greater than 0. It moves down if k is less than 0. Okay, how does the h value affect it? Okay, let's say if h is greater than 0, the graph moves right. So again, if h is greater than 0, the graph moves right. If h is less than 0, the graph moves left. So again, these are important notes to indicate how, when you have a quadratic function in vertex form, how your parabola is affected, determining whether your h is positive or negative, or your k is positive or negative. Okay, sorry class, it should be vertex form, not vertex form. So I took out the s, so please indicate that. Look at an example when dealing with vertex form. So in this case, we want to graph each quadratic function. We're given the function g of x equals -3 times the quantity of x plus 1 squared minus 2. A few things I want to note. My a value is -3, therefore my graph will open down. Okay, my h value is actually -1. So even though this right here represents my h value, remember in vertex form, and I'll write it over here, g of x equals a times x minus h squared plus k. Because in the form we have minus h, therefore whenever you see a plus here, that indicates that your h value is negative. And I'll go over this more in class, but just remember that because it's a plus, your h value is actually negative. Okay, because it's a negative, this means I am going to, let's do back in red, I'm going to move left. Let's indicate our k value. Our k value is also negative, and that's -2, meaning this will move down. Okay, so let's go ahead and set up a table. Well, before we set up the table, I can actually figure out what my vertex is. And my vertex is at -1, -2. Because remember that your vertex is your h value and your k value. So again, right away, just looking at the vertex form, we can pick out the vertex. So our vertex is at -1, -2. I can go ahead and plot that on my graph. So I go over -1 down -2 units. Okay, from here, I do want to create a table. I'm going to create a table that's a little bit different. I'm going to have my my inputs and outputs in a row instead of in a column. Okay. And let's go ahead and position this. Okay. Okay, let me just divide this up. So let's have our x values in the first row and my outputs, meaning my g of x, in the second row. Because my vertex, my x value is at -1, I actually want to start -1 in the middle. And I know that output is -2, meaning I want to choose 2 values to the left and 2 values to the right. So if I'm choosing 2 values to the left, let's do -2 and -3. And then 2 values to the right would be 0 and 1. So I'm not going to go over the steps of me substituting these values into the quadratic to get my output. You can always do that on your own to get your response, and we'll do more practice with that in class, but just for right now, I just want to show you what the outputs are. So when I substitute in -2, I get -5. When I substitute in -3, I get -14. When I substitute in 0, I get negative 5. And when I substitute 1 in, I get negative 14. So I'm going to go ahead and just plot those points. So negative 2, negative 5 would be right here. 0, 5 would be right here. And negative 3, negative 14 be right there. And 1 and 14 would be right here. I'm going to go ahead and sketch this curve. So it would be something like this. Remember, it is a curve. The parabola is always a curve. Might not be the perfect curve, but remember, it is always a curve. Okay, I'm going to draw the arrows to indicate that it will continue going down till negative infinity. So let's note a few things. We did state that this would open down, which it does. Notice that we stated that because h is negative 1, we move negative 1 units to the left from the origin. Notice when we stated k is negative 2, we move negative 2 units down from the origin. And notice that the vertex is at negative 1, negative 2, which is our maximum.